Hey guys, welcome to day one of digital learning. This is for Friday's lesson. We started the chapter 11 out of 12, so we're going to try and get through the rest of this. Hopefully we'll come back, but if we don't, we'll finish out our review on this format also. So I have uploaded into modules this sheet. You should print it out so you can write on it. If you can't get your printer to work, take out a piece of paper and you can do the work on there. Just make sure you use all the proper notations and everything along the way. There's a data set included with this in the module. I talked to the people who were available on Friday and asked them how many hours of sleep they slept last night. So it is recommended that teenagers get 8 hours of sleep at night. I believe the AP Stat students are getting less than the recommended 8 hours sleep per night. To test my belief, I took a random sample of 10 students in class and recorded the number of hours of sleep for each. Does this data provide convincing evidence that the AP students get less than 8 hours sleep per night? So I went ahead and combined both classes together. And from our data, I ended up with a sample mean. You should put this in your calculator and make sure you get the same thing of 7.14. And I got a standard deviation of 1.38. So these are in hours. I asked, how many hours of sleep did you get last night? Now, if you do not have a calculator, my email said you should download the app if you have an Android, WabaEmu. If you don't have Android, Apple is TIA X84. Check the email to make sure you can download this because you need to have a calculator to be able to do these problems. All right, so let's state our hypotheses here. So the recommended is 8 hours of sleep. So that's going to be our null. Your null is always no difference. So the mean amount of sleep needs to be 8 hours. Our alternative is, well, we got 7.1 hours. So I think the mean is less than 8 hours. And we're going to find our parameter. Mu is the true mean. Hours of sleep for AP Stat students at Etowah High School. All right. So what conditions have to be met? We have to have the random. Well, was this random? It was not. I asked who was here because there was not very many people in school. So we're going to say no, but we're going to assume the people who were there were a pretty decent sample. We're going to continue anyhow because it was extenuating circumstances. Okay. It's always safer. If you have a free response and you don't think something is met, you continue and you just make note that, yeah, I see this, but we're going to go on. 10%. 25 is not less than 1/10 of all AP Stat students at Etowah. However, we can assume it's independent. We assume your answers are independent from each other. All right. Our problems that we get that are set up for a free response have a better outcome sometimes than our simulations. So normal, put your data in your calculator and take a look at the graph. I did the histogram because our n is less than 30. We need to sketch the data. When I look at it, I don't see, there's no strong skew and no outliers. And we're just going to do a quick little sketch of it here. Try to make a decent one. It's kind of hard, but you're trying to get the point across of what you looked and this is what you saw. It's kind of what it looked like on my calculator. Your calculator might have slightly different bins, and that's okay. So just go ahead and give it a draw. So no strong skew, no outliers. So give the formulas for the mean and standard deviation of the sampling distribution of X bar and calculate their values. Well, we've talked about this before. The mean of the sampling distribution is the same as the mean for our claim, which is 8. Okay? The standard deviation of the sampling distribution, because it is a sample, you got to take your standard deviation and divide by your square root of n. So in this case, we're going to do 1.38 divided by the square root of 25. And that's going to give us a standard deviation of 0.276. All right, so we're going to calculate our test statistic here. Now, how this is different, because we're talking about means and our standard deviations coming from our sample, we have to use that t-distribution, okay? So the t-distribution formula looks a lot like the z. It doesn't really set up a whole lot different. And we're going to have this sample standard deviation divided by the square root of n. So it works the same way, but when we draw our picture, we're no longer talking about a normal curve. We're talking about a t-curve. So here we have our curve, and instead of n and then the mean and standard deviation, I'm going to put t and my degrees of freedom. I had a sample size of 25, so I have a degrees of freedom of 24. Okay. The mean recommendation is 8. We got 7.14. And so we're looking for this area over here. What's the probability of being in this area? So let's get our t-score instead of our z-score. You can take, remember, your mean minus your parameter divided by the standard error. So we have 7.14 minus 8 divided by the number we got right up here just a moment ago. And I got negative 3.12. So that's more than 3 standard deviations away from the mean. We know that's going to be significant because that's so far out, but let's get our p-value here. So the way you're going to get your p-value is, because we're working with means, we're going to use the t-table. So I brought one here for us to look at. We need to go to our rows. So go to your row for degree of freedom. Which we remember is n minus 1, which is 24 in this case. And then scan across to find your t-value. Scan for t-value. All right, well, here's the problem. This is kind of a summary. So let's take a look here. We have a degree of freedom of 24. And here are all my t-scores. And as I go across, I'm looking for negative 3.12. And so they only ever show the positive. That's fine. You can ignore the negative. So it's somewhere between these two numbers. Okay? So when we see 3.091 to 3.467, my value is somewhere between there. So what I'm going to do is I'm going to create a range of p-values. So I'm going to go to the very top. Here's my range of p-values. So my p-values are going to be 0.001 to 0.0025. So when we do this, we need to have both of these be below our alpha in order for us to be able to reject. So if both p-values are less than alpha, then you'll reject. If one p-value is less than alpha, you have to fail to reject. They have to both be below, fail to reject. And if both p-values are greater than alpha, you're going to fail to reject. So in this case, both of ours are less than alpha because we have this range right here. So because our p-value 0.001 to 0.0025 is less than alpha equals 0.05. We're going to reject. We have convincing evidence. Etowah High School AP Stat students get less than 8 hours of sleep a night. All right, so we have convincing evidence here. So the big takeaway from this is you have to, we're talking about a T distribution because we got our standard deviation from our sample. So this is not a normal distribution. This is a T distribution. And it's different once you find your T-score to go onto the chart at your degree of freedom and scan across to get that value. All right, so take a look. Here's our summary for our notes. Our conditions, random. It's a random sample. It wasn't in this case, but we had to do what we had to do. Normal, it's one of these three things. It's either the population is normal, your sample size is greater than 30 and you have a central limit theorem, or you're using the data and you're looking for no strong skew or outliers and you need to sketch that data. And your 10%, your sample size has to be less than 1/10 of your total population. Your test statistic looks just like the z-score. You take your statistic minus your parameter divided by your standard error. When you're going to draw it, you put your mean right in the middle. It's T and whatever your degree of freedom is. And depending on what you get, where you draw the line and shade. If it's on the plus side, you shade above. If it's on the minus side, you shade below. Our p-value, that's you use table B. Go with your degree of freedom and your tail probability. You may have a range for a p-value. If both are within the range, you're going to reject. Or if they're both below alpha. If only one of them is below alpha, you have to fail to reject. If both of them are greater than alpha, let me change that for you. Both of them are greater than alpha, you have to fail to reject also. So your assignment is to do the check your understanding. When you complete it, take a picture of it, and I will have an assignment for you on Canvas and upload your picture there. Please email me if you have any questions. Bye.